In this video, we will look at revision exercise 10. You will find this on page 468 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Now, this is the kind of sums that you will find in a test or in the examination. And it's almost like a revision, as it said, of further trigonometry. And I'm going to show you how to approach it and then also solve it. Okay. So by sketching a suitable pair of graphs, show that there is only one value of x in the interval. X is bigger than 0 and smaller than a half pi. That is a root of the equation. Okay. So let's start with number 1. Now again, you can do it in this video like this. You can do one or you can do the whole exercise and then watch the video. I'm going to break it up in 2 parts. I'm going to do 1, 2, and 3, and then in the second part 4 and 5. As you wish, but very important, try to do it on your own before you watch the video. Okay, so number 1, it's going to be cot x is equal to y. Basically, from this equation, I can see the 2 graphs. The one graph will be y is equal to cot x. And the other graph will just, I made a mistake there. Can I just correct it? It's equal to x. And the other graph is going to be y is equal to x. So there is your 2 graphs. This is the first one. This is the second one. Now, because this is like a revision, I want to take you back to where we did this. I think here. Can you recall? If you go back in the textbook and you look on page 438, I'm just going to make it a bit bigger. And actually it was there, and also I will take you to the summary. So what we said, if we cot x, we likely draw the tangent graph. There was the tangent. Then we draw the vertical asymptotes through its zeros. So there it was 0, there it's 0, there it's 0. Now one cycle occurs between 0 and pi, but there are vertical asymptotes at each of the circles. The asymptotes that occur at pi repeats every pi unit. Now note, this is what I want you to see. The graph of y equals tan x and y equals cot x lie in opposite directions. Where this one was going like this, and there was the full one, this one is going in the opposite direction like this. Now basically, I'm asking you, if that is pi, that will be pi over 2. So I'm asking you to draw that part. Okay. I want to take you back to that again, to the revision exercise. Can I just go back there? I also want you to take you to the summary page. So really, this exercise is for me that you almost conquered this chapter and that you can make use of the different things. So I'm just going to take you to the next page. Okay, I want you, this is the summary page, and this is very important, and I said it in previous videos. Memorize the basic shapes. The normals one is easy, sin, cos, and tan, but the cosec one, it's the u's. Can you remember? And it's like it's a full U and a full U between 0 and 180 and 180 and 360. The sec one is like a half, and the full one is there between 90 and 270 and a half again. Memorize it. And there is the cot one in opposite direction. So if you memorize these basic ones, then it's very easy if you must go back and you must handle a question like that. Okay. So I'm just going to get a grid. Always, it's very important. Don't just make it too rough. Take at least a grid, and at least you don't have to need grid paper. You can just work with 1 centimeter with your ruler. So with your ruler, you can basically just go and draw, and take a ruler, please. This is my ruler. Okay, you can basically just draw this. I want to take it a little bit lower. Up to here. Okay, and now I can just say, okay, and then you can just decide, say 2 centimeters. So if this is, say for example, 2 centimeters, and then another 2, 1, 2, 3, 4, but just make the spaces the same. So if this is going to be pi, this is going to be pi over 2. And now remember that that curve is coming like this and then it will do this. Can you remember? Can I show you again here? It's coming up. It's coming like this and then it will go down. Let's just see if I did that. Okay, let's just go to the previous again. Oh, it's a little bit slow. Okay, so it's if I draw that graph, it's going to be something like this, and then it will. And remember that here was your vertical asymptote. And it's actually here also, so it's not touching that line. Okay, from the original one. Okay, so basically this is the one. Now y equals x. Now if, say for example, you were working in centimeters and you make your units, now this is sometimes a bit more, it's just in between, but it doesn't matter as long as you're going to just write it. This is pi over 2, so let's just make this, I just want to take the yellow again. They make it 0, make it 1, make it 2. Okay, so if I'm working on the same, because pi over 2, the unit is a little bit difficult, so let's just shift pi, divide 2 equals, it's 1.5. Okay, so it makes it a bit difficult with this graph because it's 1.6, say 1.6. Okay, so in this case, it's just going to be quite a bit challenging, but I can quickly do this. It's just in the middle. Whatever the y value is equal to the... So if this is, say, 1.6, the best will be just to find that 1.6 also there. Do you see there? So it's going to be here and there. If I work on the units now to make it a bit more accurate. But it's not going to influence your answer. I just worked it out. Pi divided 2, it's about 1.6. So it must also be about, if this is 1.5, then it's 1.6. Then I can just draw that straight line. And again, I want a ruler. Okay, and I can just call this one, just name your lines. This is y equals x. And this yellow one is y is equal to cot x. So what I want to see from this graph is the following, and you can write it like, it intersects, so therefore, okay, you can say the two graphs intersect one time. Therefore, you can go and say only one root. Only one root 4. And then you go cot x is equal to x in the interval. This is important. And you can just say pi over 2 is bigger than 0 and smaller. Oh, x. Okay, I didn't write it nice there. Let's just write it better. Just make x there. X is bigger than 0 and smaller than pi over 2. Okay, but only one root because it intersects, and there's the root. Okay, it intersects just one time. Okay, and that's how you do number 1 in the exams. Now we start with number 2, and every time I'm just going to make space. Okay, and then I'm going to start with number 2. Prove that, okay, so this is a typical proof. It's just now going to be with further trigonometry, and I'm just going to get my blank again, and then it will be better. Okay, let's start with number 2. Prove that tan theta plus cot theta is equal to 2 over, now there I see my double. Do you see my double angle theta? Now you can make use of your formula sheet, but you can also make use of the summary. I will show it to you in the summary also in the next page. But let's first start with the left-hand side, because that's how you prove. And we first rewrite it. So it's going to be tan theta plus cot theta. Okay. And now, always, because I see sin there, so it's already, this is usually, I break it up in sin and cos. Okay, then I make the denominators the same. Now, just for explanation's sake, I'm actually multiplying sin theta, cos theta, cos theta. So I'm getting sin square theta plus cos square theta over sin theta cos theta. Okay, this is very nice because this is 1 over, because that's becoming 1 according to your identities, over sin theta cos theta. But now I have to look, oh, this one is 2. Now be very careful. I'm going to multiply with a 2, and if I multiply, and I'm going to write it in red, if I multiply with 2, I can do this, but don't think it's going to become now first this 2 and then 2 sin theta cos theta. And I'm going to take you to my summary. Now let's just go to the next page, or you can look on your formula sheet. Struggling a little bit to go to the next page every time. Okay, I want you to check here. I don't know why it's so slow. Okay, let me show you. Do you see there? I just want to see if I can make it bigger while I'm struggling. Okay. Do you see there? 2 sin A, cos A or theta, doesn't matter. There it is. So if I have this, in that place, I can write sin 2 theta or sin 2A, depending on what is there. So let's just go back to the previous page. It's really taking very long. Okay, do you see that? So basically, I can just go then and say this, oh, and I want to be still in yellow, is equal to 2. And then I'm going to say sin and 2 theta. It's coming from the identity. And I'm going to write the identity here for you. That sin 2 theta is equal to 2 sin theta, move it a little bit, cos theta. Okay, it's your double angles. And now you can say, okay, if I look up there, oh, that's excellent. That's equal to the right side. And that's how you prove it. Okay, let's go on to, oh, that was nice. It was just number 2. Now I'm going to look at number 3. Move a little bit, yes. Let's look at number 3. Okay, number 3, A. It's again proof. Prove the identity. Okay, so it's sin x minus 30 degrees plus cos x minus 60 degrees is equal to square root 3 sin x. Okay, now I'm going to start again with your left hand side. It's not always, but in this case I'm going to just take a brighter color. Left hand side, and that will be sin x minus 30 plus cos x minus 60 degrees. Okay, this is your compound angles. Can you recall? And again, I hope it's going to be a bit faster now. Can I just show you? Here's the compound angles. I want to move it a little bit. Okay, there it's better. Okay, so where's my compound? So this is going to be sin Do you see sin? And I think in this first one, it's going to be a negative. So, stop now. You can stop now. You can stop. Because you're so slow. It takes so long. And you just go on. Okay. So, it's going to be sin x minus 30. So, it's going to be sin. It's going to be this one. Can you remember? It's sin, cos, sin. And if that's a negative, it's a negative. And then it's going to be cos x minus 60. So it's going to be this one. But can you remember? It's cos, sin, and it's opposite sign. So if this is negative, this is positive. So this is the two that I'm going to use. Okay. See how fast it can go back to that page. Okay, so let's start. Remember, so this one was sin x, cos 30, same sign, minus cos x, sin 30. Okay, we can even put a bracket. Plus, this one is going to be cos x, and then stay with cos 60. Opposite sign, move a little bit. Opposite sign, plus, okay, so it's not so necessary to write that, but plus, and then sin x, sin 60. Okay, and then now I'm just going to look at, now this is very, very important. When you come to this, always remember this. When you see, doesn't matter sin, cos or tan, you see a 45 degrees, or you see a 30 degrees, or you see a 60 degrees, or you see a pi over 4, or pi over 6, or pi over 3. You must always go to your special angles and put values in there. So I see cos 30. I see sin 30. I see cos 60. I see sin 60. Go draw that triangle, and I'm going to draw it here for you. I just want to see where is my space better. Okay, it's not a big triangle, so I can just move a little bit, then I can draw it here. Okay. So can you remember the triangle? Quickly go then. Okay, just take my ruler. Okay, and remember it was half of a equilateral. Now if it's half of an equilateral, this was 2 and this was 1 and this is square root 3. This was the full angle, 60. This was half of it, 30, because it's going on there. And now I can substitute. Now I start. Sin and x, leave x, you cannot substitute. So you have cos 30. Cos 30, so it's square root 3 over 2. Minus cos x, sin 30. It's opposite over adjacent, so it's a half. Plus cos x, put cos 60. What is cos 60? Adjacent over hypotenuse. Plus sin x, and now sin 60. Sin, it's square root 3 over 2. Okay, so basically, I'm now going, oh, this is very nice. This is like, do you see? And this is like. And it's opposite signs, so it cancels out. And this is also like. Okay, but let's just write it down. It's going to be, this is like your variable, sin x. So it's going to be square root 3 over 2 plus, okay, let's rather write it better. Square root 3 over 2 plus square root 3, okay, it's over 2. I actually make the denominators the same. Let me rather do it like that. Plus square root 3 over 2. And the variable is sin x. So it's actually 2 square root 3 over 2. The 2's cancel out, do you see? And you end up with square root 3 sin x. Oh, and that is equal to the right hand side. Magic. Okay. That was number 8. Now let's do number B. Let's see if I can do it, because I think I'm going to use some of this information, although I think some is given to me in the question also. Let's go to number B, henge. Now I said to you, if you see the word henge, it's always to say that A will help you now in B. So now look, they repeat this and then they bring something else. So do you see that this is the same? And that's equal to this. So if I start, I can start like they start, B, by saying sin x minus 30 plus cos x minus 60 is a half sec x. Okay, now I can replace this by this. So I can, from the top, so I can say square root 3 sin x is equal to a half sec x. Okay, are you having that? And now basically I can solve that. Okay, so I can now go, and remember it's between 0 and 360. So I can go on, let's just move it up a little bit. Okay, I don't want to work with sec, so let's just go square root 3 sin x, put it over 1, and let's just move that to cos x. Okay, do you see that? And then basically what I can do, I can cross multiply. So I end up with square root 3 to cos x sin x is equal, and it's equal to 1. Oh, can you remember this from the previous page? So to get that alone, I can actually first go and I can say I divide square root 3, I divide square root 3. So basically I'm ending up with, let's just go to green again, 2 cos x sin x equals 1 over square root 3. Okay, can I just show you? Hope it's going to be a little bit faster this time. Still, I'm struggling with that. Can you remember there? If you have sin cos, 2 sin cos, you have sin 2a. Okay, or theta, doesn't matter. So go back. If you have sin cos 2, you in the place of that, you can go and substitute sin 2x. Okay, it's a double angle and it's 1 over square root 3. Okay, and now from chapter 4, you can do this. Don't forget, and I have to take you there. What was x? X was between 0 and 360. Okay, so don't forget, we're going to write it here. X is bigger than 0 and smaller to 360. And now from chapter 4, because I have 2, I have to times 2, times 2, times 2. So 2x is bigger than 0 and smaller than 720. Okay, then I have my sketch. Here is my sketch. Okay. Now, basically, this means it's not going once around, it's going 2 times around. And I say, where is sin? Where is sin? Positive. Now, sin is positive there, and sin is positive there. Okay. Now, first, I'm going to get my basic angle. Now, how do I get my basic angle? Remember, this is in degrees, so I press shift. Okay, make sure your calculator is on degrees. Then press shift, then press sin, and then press bracket 1 divide square root 3, close the bracket, equals. And I get 2 decimal places, 35.26 degrees. And now I start. Now remember, this graph is going on 1, 2, okay, due to 720. Okay, so if I start, I say the first angle 2x is just that in quadrant 1, 35.26 degrees. Now that is going to be my first. I like to leave a space just So you can do it next to each other, doesn't matter. Or 2x, and now it's this one. So it's 180 minus 35.26. Now, due to the second round, I do this calculator. I say 180 minus 35.26, and I get 144.74 degrees. Okay, leave it 2 decimal places. That's going to be my second one. But that was my first revolution. You can even say first revolution. And now I'm going to go for my second revolution. And now I'm going to say, okay, I take the first one. Okay, and what is the first one? Again, it's 2x, sorry, it's just green. 2x, and it's that 30, so it's this one and this one. So it's the 35.26 that I add just a revolution, 360. Okay, so that's my third answer. And then for my fourth answer, I'm going to again leave a space to, I want to keep to green, 2x, and now you can just work with this one, you're ready. So it's 144.74, and I add 360. Okay, and that's my fourth answer. And now I can start simplifying. So I divide 2, so therefore x is equal, if I divide 17.6. Okay, this one, okay, I take this angle there, and I also divide by 2. So x is equal to 72.4 degrees. This one, after I add, I divide with 2, and therefore x is 197.6 degrees. And this one, after I add, I divide 2, and x is equal to 252, no, let's just get that pen correct, 252.4 degrees. And if you wish, you can then conclude by writing all the different answers again. So you can say, therefore, x equals, and then you can start 17.6 degrees, or x equals 72.4 degrees, or x equals 197.6 degrees, always 1 decimal place, final, or x equals 252.4 degrees. And that is how you finish this question off. That was the first 3 questions. In the next video, I will do the last 2 questions.